So I want to go ahead and take a look at these GGLabs F2R16 EEPROM replacement modules. So these are based on flash memory. Looks like they're a 29F400 TC device. These came programmed. I bought them from GGLabs on eBay with the DiagROM high and low images for the Amiga. The DiagROM version 1.0. I want to reprogram these with the version 1.1. I could also put Kickstart images in these as well. To program these, his setup is using that TL866 programmer with the TSOP48 adapter in the programmer, and then a card that comes from GGLabs that basically plugs onto here, and then the modules will go into the card to be programmed. And basically what this is doing is I'm actually setting the device up to be this 29F400 package. Then this adapter, and normally these would drop into an adapter socket to be programmed before they were soldered on. And what he's done here with this board is basically make an adapter that hooks these together. It does require there to be 3 pins manually connected onto the board here during the programming operation. And I'm going to go ahead and assemble these. Hopefully the glare on the desk isn't too bad. So there's the F2R16 modules, the little adapter card that we're going to build up today, the TSOP48 adapter module that goes into the TL866 programmer. In my junk box, I've got a nice Textool gold pin, 40 pin, ZIF socket. No idea where I got this at or when. It's been in the box forever. We should be able to use it. It's got some solder on a couple of pins here I made to clean off. And I will go ahead and use these to make the pin adapters, the females that'll plug over the top. So I guess let's just jump into this and get it going. And the easiest way to do this is really to pull out the pin where I need to make the cut and just walk along and get enough lengths here marked out, and then cut this apart. This will be too short, and it is. So we'll need to make one more out of this long piece here. Find my flush cutters, which are lost here on the bench someplace. Let's see if I can get these to snap apart. It's not the cleanest job cutting these down this way, but they will work just fine for what I need to do here. It's not going to see high volumes of insertion and removal, but I can clean them up a little bit just to make the build look a little nicer. Again, I have no idea where I bought these. They've just been in a junk box forever, and they occasionally get pulled out for project work. Can I get that to clean up a little nicer? It really doesn't want to. I got something I can. Not that screwdriver. If I can get these to flex out a little bit, so I can get the flush cutters in there. Just trimming off the extra plastic where I pulled the pins out, make it look a little bit cleaner. should end up with one short one and 4 of them all the same length. Say it's not going to be the cleanest build I ever did, but good enough for my purposes. I've got the same issue here where I can't get the flush cutters in there to kind of trim off the extra plastic here. The biggest concern is going to be getting this guy in place. He is on a socket, which is nice. I believe this to be an actual text tool socket. It's pretty high quality. If I can get him to release from the base. Say the couple with solder on them is going to be a problem. I think it's going to be probably best to start with this. This is really just going to be a matter of fudging around with all the pins on one side and then the other. Hopefully it'll work its way on through. And oh, the whole thing just popped up out. Oh, that's frustrating. That is frustrating. So we'll try it again. Stubborn, aren't you? Those pins are caught in there pretty tight. Let's see. So pin 1 is up here. I'm just going to try to be a little more gentle with it. That entire side has started. I've got the sunlight starting to shine in through the window here, probably creating tons of glare on camera. Who are you hung up on? I can't let it rock too far or the pins will come out. There it goes. Oh, excellent. It slid down flush even with the solder on the pins. So I think the first thing to do here will be to solder this up. I'm realizing I should have put that surface mount cap on first. Crud. Well, I went through all that for nothing. Let's go ahead and see if we can get this surface mount cap mounted. I don't do a lot of surface mount. taped open on the carrier. It's trying to peel back. Got this dumped out. Get a good tip here for surface mount. I'm just going to put a very small amount of solder on one side. And hopefully slide him in and somewhat square. And tack down the other side. That was definitely easier to do with the, well, it's not pretty, but it's on. And now we can go back and do this again. So again, pin 1 is there. Go ahead and plug him in. I'll solder with the full socket in place, that way all the pins are held in. I believe whatever device this textile socket came out of, it was all wire wrapped. When I tore it down, I'm going to go to a little larger tip. Ooh, it's still hot on the soldering gun or soldering station, and hopefully not bore you too badly with soldering. It would help if I could see. It's not down flush. I'm not sure why. Well, I won't bore you with soldering the other 38 pins here. So all the pins have been soldered, and I've trimmed most of the pins off, but I thought I'd kind of demo this for you here. Hopefully I can do this on camera. As I trim these pins down, I'm going to make a point with this as I get in here and cut these remaining pins. All those pins fired into this piece of foam like they were nails coming out of a nail gun or dart, and I very quickly discovered just firing them directly into the end of my thumb was rather painful. Point being here is cutting these pins creates a lot of energy in the cut, and the pin goes flying. And if I wasn't wearing safety glasses and something to capture these pins, those pins have been flying all over the room. So Point being, use safety gear. I need a 3-pin header. I need a few pins worth. Three. Well, is that right? I do want to solder one of these onto here. Don't want to burn myself soldering it. Come on, take enough solder to hold it in place, and it's not straight. Just trying to get enough solder to tack it in place. I'm sure I'm doing this off camera. And those are used to jumper 3 wires onto the corresponding pins on this here, and there's really 3 pins and then a standalone on these, and because I'm going to be programming these, I need to add the extra jumpers here, and there'll be jumper wires that'll come off of these pins here when this is down in the programming socket here to be programmed. I will need to run jumper wires to the reset write enable and A18 between these, complete the circuit so they can be programmed, and that's why these need these pin jumpers added, because I am actually going to be reprogramming them. Let me get 2 more individual pins here. And those go into the extra hole there. An extra hole there. The problem here is those are fairly loose, so I'm going to grab a little jumper just to put across those to hold them in place square, and then I'll solder the other side of these up. Flush. It is now. It wasn't in flush, so we'll go ahead and that center pin there was ground. It took a bit of heat to get that to flow. That gets the extra pins on there. And we'll do the same thing here. And of course, the big question will be, will this all work? Once I get down on the EEPROM programmer, or the ROM programmer. We had looked at the DiagROM 1.0 in a previous video on my A1200, and the floppy test seemed to hang the machine up, if I remember right. And I know there was a comment from the gentleman that's developing the software that he would look at it. I don't know if it's been fixed or not. So really the next step here are to get these in place. Actually, the easiest way to do this is going to be to just go ahead and put them on here. And then the board. And we'll just tack the end pins And this should give me pretty good alignment. And then we'll pull it off and finish soldering it after the end pins have all been captured or soldered. Board should now separate. And I can finish soldering this up, so I don't know how exciting it'll be for you to sit and watch me solder this. But it is what it is. Well, I'll pause the video here, and when I come back, we'll take a look at these on the programmer. So we're going to go ahead and program up a couple of these. I can't talk here. The F2R16 modules. So I've got the TL866.2 software loaded up here. On the second screen, you can see that I've got the TL866 programmer down here. I've got the TSOP48 adapter. Plugged into that is the GGLabs programming adapter that we wired up all the way through to an F2R16 module up here. And then there's 3 jumper wires that come from the board itself up to the device itself, and that brings A18, reset, and write enable up to the device. So we've got this wired up so we can read and write the RAM on here. The RAM that's on here is a Fujitsu 29F400 TC. At least that seems to be, based on the reading I can do, it's kind of dim, but that seems to be the part that's on there. You can see in the programming software here, I have entered 29F400 and picked the Fujitsu, that part. Let me go ahead and load up some data here. So I've got the Amiga DiagROM here, and first up I'm going to go ahead and program the low. So a 32-bit low image. Let's go ahead and load that up. And we'll load it into the tool, and there's the bytes for the low image. In order to be able to program the device, we need to disable pin select or pin detect and check ID. And I should now be able to write the device. So let's go ahead and do a device program. It's telling us to use the TSOP48 adapter, then with the stack of adapters and the jumper wires we've had to add to make this go. It's going to erase the device. Hopefully you can see the yellow LED here on the programmer blinking as data is being passed. And it's satisfied that it's programmed. And of course I can come back and do a device verify, which it just did, and we should have now programmed that image into the device. Something I've noticed in the software here, and maybe I'm just not seeing it, is the name of the file I have loaded eludes me here. But we did just load the low file. A couple things about the programming software here I like. If we go to the device info, it's telling us, of course, we're programming this device as a TSOP48. It's 512K bytes. It'll show us the adapter to use. So we've got that adapter, the red board down here on the bottom is this board down here, and then we're not using their plug-in adapter on top. We're using the one from GGLabs. And basically it's just reproducing the wiring that would be on here to get to all those device pins. So that's kind of a neat feature. So let's go ahead and remove the Diag low ROM out. Let's plug in the high one. I'm just trying to It should be orange, white, blue. Yeah, those are still in the correct order. Drop him down in. If we verify now, this will fail because it's got a different image programmed into it. So if we do a verify, it'll fail very quickly saying there's an issue. Let's go ahead now and load the high bytes, high words, this image here into the buffer. We can see the data changed here. And we can go ahead now and do a device program. And program. And again, remember, you need to disable pin detect and check ID. I had to disable both of these before it worked, and I believe in the notes I found from GGLabs, those are both required steps. Now, of course, we could also be programming in Amiga Kickstart versions if we wanted to here. So it looks like we are done here. It did a verify. I'll do a second verify pass just to do it. Verify's finished, so it does believe the two devices are programmed. I'm not sure there's a whole lot else out here we can do. You know, the software seems adequate. It seems to do a pretty good job. I like the fact that it'll show you the correct stack of adapters that came with it to put together to program your device. So pretty cool. So I think the next thing is I will throw these in my Amiga 1200 and see if they work. Anyhow, I think I'll wrap this video up here. We've gone through the assembly of the cannot talk here today. The F2R16 programming card. It's the green board here with the zip socket in it. We've gone through we assembled that up. We've tested the TL866 programmer, verified it's legitimate, not a clone, loaded the software, updated the firmware. Everything seems to be working as expected. So this really is, I hate to say it, what I bought this stack here for. So just another programmer that get added to my little stash of programmers. Anyhow, as I said, I'll wrap this video up here, and we'll talk soon.